So, NVIDIA just dropped its latest roadmap, and wow, it is about way more than just making chips faster. They're building what they call an AI factory, and it's a concept that could totally reshape the future of computing. Let's break down what's really going on here. Look, we've all seen what AI can do, right? It can help write code, generate incredible images, act as a super smart chatbot, but we're not going to talk about that today. We're going a layer deeper. We're going to look past the apps and focus on the revolutionary new kind of computer they're being built on. And this quote from NVIDIA's CEO, Jensen Huang, just nails it. He says that every decade or so, there's a major reset in computing. But this time, it's not one, but two happening at the exact same time. First, we're building completely new kinds of applications on top of AI. And second, the way we even create software is changing. We're moving from programming to training. This isn't just a simple upgrade, you guys. It's a whole new foundation. So let's see what that foundation looks like. Okay, so the very first layer of this new world is something called agentic AI. This is a huge leap. We're moving past the simple chatbots that just answer questions and giving AI a brain that can actually get things done. So what the heck is an AI agent? Well, think about it like this. It's a system that doesn't just sit there waiting for your next command. It can take a complex goal, like plan my trip to Tokyo, and then break it down into smaller steps, use tools like a web browser or your calendar, and then actually execute that plan. It's the difference between asking an assistant for a phone number versus just saying, hey, schedule the meeting. NVIDIA showed off this really cool demo with a little desktop robot named Richie Mini. When they asked it what was on the to-do list, it didn't just pull up a file. No, it used its camera to perceive the room and read a sticky note on the wall. That's step one. Then, when it was asked to email the CEO, it reasoned that, okay, to do that, I need to use an email tool. That's step two. And finally, it acted. It actually opened the app and sent the message. Perceive, reason, act. That simple loop is the core of all these new agentic systems. Now, the tech behind this is where it gets really clever. See, it's not just one single giant AI model doing everything. It's way smarter than that. First, it's multimodal, meaning it can see, hear, and read. Then it's multimodal. It has this intelligent router that picks the best AI for the job, maybe one for writing and another one for creating images. It also runs on a hybrid cloud, so it can keep your private stuff, like emails, right there on your device, but tap into the massive power of the cloud for the heavy lifting. And the most important part, it uses tools. It connects your other apps to actually get stuff done. That combination is what makes it so powerful. Okay, so we've given AI a brain. That's huge. But what happens when you give that brain a body and senses, and you let it loose in the messy, unpredictable physical world? Well, that takes us to the next layer in this whole stack. And that brings us to the second massive piece of this puzzle, physical AI. This is all about teaching AI the laws of physics, giving it common sense, and training it to operate things like cars and robots safely out here with the rest of us. Let's use self-driving cars as an example, because it's perfect. The leap from the driver assist we have today to true, full self-driving is just enormous. And it's not just a tech problem, it's a legal one. Right now, in a level 2 system, you, the human, are always responsible. But once you hit level 3 and up, the computer is legally responsible. The AI isn't just helping you anymore, it is the driver. That is a fundamental shift. So why is this so mind-bogglingly hard to get right? Well, the CEO of Mercedes-Benz put it perfectly. He said, getting a car to handle 99% of driving situations, that's the easy part. The real challenge is what he calls the long tail, that almost infinite list of weird, rare, unpredictable things that could happen. A deer runs into the road, a bizarre construction setup, a weird reflection. You just can't collect real-world data for every single one of those crazy scenarios. So how in the world do you solve for the long tail? Well, you can't just rely on real-world driving. And this is NVIDIA's whole approach with their new AI driver, Alpamo. It starts with data from human drivers, sure. But then, and this is the key, it uses a world simulation model called Cosmos to generate insane amounts of synthetic data. This lets the AI practice millions of dangerous situations safely inside a computer. The AI gets trained end to end, learning to go straight from what the camera sees to hitting the brakes. And maybe most importantly, it's also learning how to reason and explain why it's making a decision. So we've got an AI with a brain and an AI with a body, but to train that body to handle all the craziness of the real world, you need an engine. And I'm not talking about a normal engine, you need something absolutely ridiculously powerful, a completely new kind of computer. The demand for AI computing power is just exploding. I mean, look at this. The size of the models is growing 10 times every single year. The amount of data they're generating is growing 5 times. And all the while, there's this huge pressure to make it 10 times cheaper. You just can't keep up with that kind of exponential growth by making chips a little bit faster. You need a totally new architecture. And this is where you can really see NVIDIA's big strategic move. They're not just a chip company anymore selling you individual GPUs. They are selling an entire pre-built platform. So instead of companies buying all the parts and trying to build their own supercomputers, they can now just buy a complete, ready-to-go AI factory on a rack. Everything from the chips to the networking to the software is designed to work as one single massive computer. And the performance of this new platform is just wild. It's named Vera Rubin, by the way, after the amazing astronomer who discovered dark matter. At its core is the new Rubin GPU, and it delivers a 5-fold jump in AI inference performance over their last generation. Now, let's be clear. A 5x improvement is not a small step. It's a massive leap, and it's built specifically to handle that insane demand we were just talking about. It makes real-time AI, like in a self-driving car, not just possible, but actually efficient. All right, so when you start putting all these pieces together, the brain, the body, the engine, you finally start to see the grand strategy here. NVIDIA isn't just playing in one area. They are building the entire stack, from top to bottom. Let's just walk through it. At the very top, you have the applications, those agentic AIs we talked about. Underneath that, you've got the physical AI, giving those agents a body in the real world. Powering all of that is the Vera Rubin platform, the AI factory. And then, at the very foundation of everything is the silicon, 6 different chips, all designed from the ground up to work together as one cohesive system. When you boil it all down, NVIDIA's goal is incredibly ambitious and pretty clear. They want to build the entire set of foundational tools that the whole AI industry runs on, from the software and the AI models all the way down to the custom chips inside the AI factory that powers it all. It is a complete end-to-end vision for this massive shift in computing. And that leaves us with a pretty fascinating question to think about, right? We just walked through the architecture for a new kind of intelligence, an agentic brain that can reason, a physical body that can interact with the world, and an engine powerful enough to run it all at a massive scale. So the question isn't just what we can build with AI anymore. The question is, what will this new, more capable AI start to build for itself?